Okay, so here's to answer a couple of your questions. So one of them, I think, was this kind of problem. You can see that in here, this is a quadratic. So you're going to want to break it down to its simplest form. So you're going to want to factor it. So a quadratic always breaks down to two binomials. Well, not always, but most of the time. So you want to look for what multiplies to 16 but adds to 8. So that will be 4 and 4. So I know this is going to be x plus 4 and x plus 4. If you're not sure, remember that you can take your factors of your quadratic and you can FOIL them back together. You can multiply it back together just to check. So you can see that x squared, these two are going to go together and make 8x and 16. So I know that for sure that this is equivalent to this. Okay, so I'm going to erase that to give me more room. So now that I broke it down, you can see that you've got you've got two sets of x plus 4s in the numerator on the top, and you've got an x plus 4 on the bottom. So both of them are under the radical, so I can write them both under the one radical if I want. And if I have something that's a numerator and the exact same thing that's a denominator, I know they'll cancel and make one whole. So now the answer is the square root of x plus 4. Okay, and the next problem you had was the square root of 50 x squared over 169. So when you have a fraction inside the radical, you can separate them to two separate ones, or if it's easy to simplify inside, I would do that. Just looking inside here, nothing really goes into 50 and 169 evenly that I can think of right away. So I'm going to go ahead and split them into the square root of 50 x squared over the square root of 169. That's going to help me because I know the square root of 169 is 13, because 169 is 13 times 13, and that's the same as 13 squared. And I know that the square root and a squared will cancel themselves out, and I'll just get 13. So I know that the bottom of the fraction is going to be 13. The top, I know that 50 is made up of, there's a lot of things that make 55 times 10, but neither one of those are perfect squares. 25 and 2, that's going to be helpful because 25 times 2 times x squared. I know that the square root of 25, I'm going to go ahead and write it down here. I'm out of room. Just remember that the bottom of the fraction is 13 when we write the answer. So I know that the square root of 25 is 5, because 5 squared equals 25, and the square root of 5 squared is 5. So I know I'm going to have a 5 up here. The square root of 2, there's no way of simplifying the square root of 2, so I know my answer is going to have a square root of 2 in it. And then, and then I had x squared, the square root of x squared, and I know that the square root and squared cancel themselves out and make x, so I'm going to have an x out there. So my answer is going to be 5x square root 2 over 13. Then on the last one that you asked was 12a to the 12th and b to the 5th. So you know how I've been showing you that squared and square root simplify themselves? So I'm going to see if I can write this all with powers of 2. 12, if you think about the things that make 12, 6 times 2 does, but that doesn't help because 6 and 2 aren't perfect squares. But 4 times 3, 4 is a perfect square. So I'm going to write these all separate. I've got 4 times the square root of 3. A to the 12th I'm going to put those into twos, sets of twos. There's 2, 4, 6, 8, 10, and 12. Got squishy in there. And I'm going to write b to the 5th in terms of 2. So that's 2, 4, and then I've got 1 left over. So now what I want to do is look for things that I can simplify. Well, square root of 4, I know that 4 is 2 squared, so I know that simplifies to just a plain old 2. Square root of 3 I can't do anything with, so I'm going to put that in my answer so I don't forget. Square root of a squared is a, so then I got an a here, an a here, an a here, an a here, and an a here. So I got 1, 2, 3, 4, 5, 6. So I have 6 a's on the outside of the radical. B squared is b, and there's another one. So I got 2 b's on the outside of the radical. And then I've got this b that's sitting on the inside, so I'm going to put it in here with the 3. So there's my final answer. Hopefully that helps. If not, email me with more questions or specific problems, or a specific question that you had on this video, something that didn't make sense. Just let me know.